a really quick lecture on the law of reflection. This is probably one of the most foundational, easiest laws to keep track of when we're talking about images and light and optical instruments. And it is very intuitive if you are a pool or billiards player. So very similar to our law of momentum back in our kinematics unit. So you go back and check out conservation of momentum, and you already have half of the law of reflection. All right, let's imagine that we have a flat horizontal surface, and I have a ray of light that's coming into that surface. So a lot of terminology here. This, like when we talked about refraction, this is our incident ray. And if this is a reflective surface, that incident ray is going to bounce, and it bounces in a very specific way. We first have to appreciate the angle at which it hits the surface. So this is just like in refraction. This is the point of incidence. And of course, we take the normal to the surface at that point of incidence, okay? So the normal to the surface at that point of incidence. The angle between the incident ray and the normal is our angle of incidence. So that's sub I. This is our angle of incidence. Now the law of reflection tells us that the angle of reflection is equal to our angle of incidence. So my reflected ray will head off in a direction that is equal to the angle of incidence. Again, those angles are measured with respect to the normal at the point of incidence. So as soon as I start to curve the mirror, either in a bow shape or a boat shape, we have to look at that tangent to find out the angle of reflection relative to the tangent, the normal, relative to the tangent at that point of incidence on that curvature. And that's how we look at the way light rays are reflected in curved mirrors, convex, concave mirrors. Okay, so regardless of the surface, remember that is what is going to happen. This has been a smooth surface, but what if the surface is rough? So we can look at the law of reflection to explain some fun phenomenon. For example, if you look out on a lake, a nice smooth lake early in the morning when there's no wind, you see a beautiful reflection of the surrounding area, the sky, everything. It's almost crystal clear. It's as if the lake was a sheet of mirrored glass. But on a windy day, you get no reflection. Why might that be? Well, when the lake is smooth, all of the rays of light are reflected parallel to one another. So if I drew another ray of light here, I would get a parallel ray reflected, and they all hit in a very consistent pattern in my eye, as if it were what's called a plane mirror. And go check out the video on image formation in a plane mirror. But if the water is rough, so I'm just going to be dramatically rough here, then parallel rays of light. So if I bring in a light ray. Well, now I have a curved surface, so I have to find its tangent, and then I take the normal. Ooh, this is really tight, and this ray of light is going to be reflected really tightly. A parallel ray of light, well, that's going to hit a totally different part of that rough surface. So again, it's parallel to this one. So I got to take its tangent. Well, that gets reflected in that direction. So none of these light rays are getting reflected in a consistent direction. Parallel rays light coming in are not being reflected parallel, and therefore forming an appropriate image. Instead, they're forming the same light rays are moving all over the place. And we can't interpret that image because there is no image created because nothing is consistent. So also gives rise to why sequins on a fancy dress sparkles, right? If you look at a piece of sequins, there are many different facets of that piece of sequins. And therefore the light rays that are coming in parallel are being reflected in all directions. And as the person wearing that sequence moves, the light rays are being reflected appropriately and giving that sense of shimmer and shine and glistening and sparkle. And so we can use the law of reflection to understand very concrete ways images are formed in mirrors, to understand some of the phenomenon like on lakes, for example, and the beautiful sparkle of a sequins evening gown or fancy vest. All right, good job.